In the first video for section 3.3, we had seen one version of the chain rule, and this was if y is equal to f of g of x, composition of two functions, then the derivative y prime is f prime of g of x times the derivative of g of x. Okay, so you keep the inside as it is at first, you take turns, and so there's like a chain of events. Okay, so if you're going from f of x, and you have f of g of x, and then you're taking care of that inside function. In the second version, we look at it as if you have y as a function of u, okay, f is a function of u, where u is a function of x. So it's essentially the same thing, because if you sub g of x inside here, you get that back. But this shows you the chain in a better way. So if f is a function of u is a function of x, then the derivative of y, dy dx, this is a better notation for this rule, dy dx, it's the derivative of y in terms of u times the derivative of u in terms of x. So again, this is that piece, and g prime of x is that piece. It's the same thing, just using a different notation. This might seem confusing at first, but let's do a couple examples to show you how it works, and hopefully it'll make sense. So the first thing we need to find here is dy du, the derivative of y in terms of u. Here's y in terms of u. So dy du, okay, the derivative of this in terms of u is just 6u. That's it, we're done. The next thing we need is du dx, the derivative of u in terms of x. U in terms of x, right here. So the derivative of u in terms of x will be 4x to the third. Now, so we did two things, and then the last thing is find dy dx. But what is dy dx? It is the product of these two from the chain rule. Okay, so if I take dy du, which is 6u, times du dx, which is 4x cubed, I'm almost done. That's dy dx, but I want everything in terms of x. This is what that notation means. This is in terms of x, this one isn't. We'll replace it. U is right here. U will go in that spot. It's x to the fourth plus 7, and that's 4x cubed. This takes a little getting used to, so watch the examples again until you understand it. So for this one, we need dy du, y in terms of u. This is u to the 1/2. So dy du would be the half comes down, u is raised to -1/2, and that's it. Next we need du dx, u in terms of x. So that's 6x. And finally, the chain rule comes into play now. You have to multiply these two to find dy dx as per the chain rule. So it's half u to the -1/2 times 6x. But half u needs to be replaced. It's 3x squared minus 1 to the -1/2 times 6x. Now, if you had done this problem differently, if you had been given y equals the square root of 3x squared minus 1, put this up here, if this had been the question, then you would have rewritten this as 3x squared minus 1 to the half, and then dy dx, or y prime, the half would come down, 3x squared minus 1 to the -1/2 times, you go inside, do the 6x, the original version that we saw in the last video. And this matches what we have here. Okay, so it's the same thing, just a different notation. Okay, question 3 is giving us some data points. There's no functions given. It's saying suppose h is f of g, and find h prime at 0 given some information. So h prime, so this is, let's call this h of x. X could be our variable. So it's f of g of x, fog, f circle g, that notation. We've seen it a long time ago. So if I want to find h prime at 0, I need h prime at x first. Chain rule, it's f prime of keep the inside times g prime of x. Now since I need h prime at 0, I'm going to plug in 0 for x. So h prime of 0 is f prime of g of 0 times g prime of 0. We know g of 0, it's right here. So it's f prime, start from inside, g of 0 is 4, and g prime of 0 is given, which is just 2. And f prime of 4 was also given, it's negative 3, so it's negative 3 times 2, the answer is negative 6. Now this bothers some people because you use this information, this and this, but you never use this. But that's something to get used to, because in the real world, if you're doing a project, you may not be using all the info, but only certain relevant pieces, and that's what's happening here. Okay, last question, going back to the equation of a tangent line, which is y minus y1 equals m, that's the key, times x minus x1. This is your x1, this is your y1, we need m. So we go there to take the derivative to get m. We need product rule, chain rule. So derivative of the first, 2 comes down, 3 minus 2x raised to 1, go inside, chain rule, get a negative 2. Now you're going to keep the second one as it is, don't do anything to x plus 1 quantity cubed. Y, product rule. Keep the first one as it is. Now take the derivative of the second one, chain rule, 3 comes down, x plus 1 squared. Then you go inside, the derivative of that is 1. So just to make sure we caught this, we used the product rule. So you took the derivative of the first, the 2 comes down, and this is as it is, raised to 1, then you go inside, take the derivative, keep the second as it is, plus, keep the first as it is, take the derivative of the second, chain rule again. Now we need to plug in 1 to get the slope, f prime at 1, it's 2 times, so I plug in 1 there, it's 3 minus 2, which is 1, negative 2, 1 plus 1 is 2, so it's 2 cubed, plug in 1, 3 minus 2 is 1 squared, plus 3 times, that's a times, 1 plus 1 is 2, get squared. So that's negative 4 times 8, negative 32, that's 4 times 3 is 12, so the slope is negative 20. We're almost done. It's y minus y1 from this point equals negative 20 times x minus x1. This is your tangent line. Alright, that's the end of this worksheet. Be sure to try the homework. This is as far as we go for exam 2.